So Peter, tell us what we're looking at here.
This is our fatigue tester. We want to make sure that our bikes are durable. So the best way to do that, two ways to do it. One way is to start selling them and see who breaks things. But somebody might get hurt, you could ruin your reputation that way. So we built a machine that weighs 400 pounds and it'll push up to 2,000 pounds on the frame. And right now we've got
about what I push.
What's that about? Yeah, those massive legs.
Yeah,
I see that. Yeah. So right now we've got a linear roadster frame in it. This is the first non-defective frame that we put in there. And the problem we're having now is that it's been 750,000 cycles and nothing's broken yet. So we're kind of running out of time. We've got 2 more frames we want to test, and
750,000.
750,000. That's it. It's pushing on the seat mount. This cylinder is pushing on 850 pounds, 750,000 times. And these are each pushing on the pedals about 90 pounds, and they've done about 250,000 cycles apiece.
Wow.
So it's creeping up on 1 million.
Now how long does it take for that to happen?
1 million takes about a steady month, consistent month of running. And actually I haven't checked, but I'll bet you we can go back to our electric bill and tell what months the fatigue tester was on, because on the other end of this is 7 horsepower compressed air, which it doesn't run continuously, but it goes on and off.
Is this just fed off the shop's
Yeah, it feeds off the shop air system. So the noise is way out back where you don't have to deal with it. Actually, usually this is way out back where you don't have to deal with it. But for you, we brought in a warm room that's nice and heated and stuff.
Now, did you build this all yourself, or did you have some help with this?
We came up with the concept, and then we worked with a linear owner who is a teacher at Purdue. And he worked with 4 senior engineering students to do the construction. To do the detail of design and construction. And since then we've changed a bunch of things. You can see this is the most recent change. It's not even painted yet. No. But the problem we had with the first design, you see down here there was something's been ground away from it. There was a clamp here that clamped around the rear hub to support the back of the frame. But on our tester, when you push on the pedal, the crank rotates and it pulls on the chain, and the chain pulls on the back of the frame, and the back of the frame can flex. Well, if the rear hub is bolted to the steel, the frame doesn't flex. You're not testing this part of the frame. So this, we hang it from these straps, which are somewhat flexible, and it's allowed to flex a little bit. We're probably going to add hinges in here before too long, because I think it should be a little more flexible than that. But you can see, we'll turn it on a bit, and you'll see it is flexing.
So you're trying to make it, it's a more extreme, obviously. There's not too many 850-pound riders that are on your bikes, but you're trying to make it more of a real-life pedal action rather than just bending and twisting the frame and seeing what happens.
Right. Yeah. And the 850 pounds, that's a large rider hitting a massive pothole. Mm-hmm. We put a 240-pound rider on a bike, and we put a laptop on it and strain gauges and accelerometers in the frame, and race through potholes and analyze that data to come up with, when you hit a hole, how many times your normal weight is suddenly applied to the frame. So we came up with a number, and that's where we're getting that from. So when this hits 1 million cycles, we'll uncork a bottle of champagne, and then we'll turn this valve all the way up, and this valve all the way up, and the 850 pounds will go to 2,000. Mm-hmm. And the 90 pounds will go to like 220 pounds. And then we'll stand back and plug our ears. But the first time we had a defective frame and it went more cycles than we cared about. And I opened the valve up and it broke in. Actually, what happened with that one was sort of funny. A small crack formed and nothing changed for like 50,000 cycles. Nothing changed. And that was a design that was already obsolete. We were producing that. We actually had only sold one like that. Mm-hmm. And it was cracked. I knew where it was going to break. I just wanted to break it and get it out of there. So I opened it all the way up, and 2 or 3 minutes later there was a loud bang, and the thing got bent really bad. But it works well. So this adjusts the seat pressure here, the big cylinder, and this adjusts the pedal pressure, so they're independently adjustable. And
now this is not I know you said before when we talked about this, you break the machine more often than you break the frames. Where do you normally break the machine in?
Well, the first thing we did, you see it's pulling on a chain there.
Mm-hmm.
So we started out with a used chain from like a 10-speed,
Mm-hmm.
and we broke it 8 times. So then we put on this heavy chain. See the difference in those two chains. So this is the extra heavy duty frame. It's for freestyle bikes.
Okay.
Really, grinding against
Yeah.
concrete steps and stuff. And so we put the heavy chain on, and then we broke the rear hub axle, and then we broke a frame. Most recently, we broke the crank arm, and then we broke the chain, the heavy chain. So we just put it back together, and we've eliminated a bunch of chain. We put in the turnbuckle here,
Yeah.
and steel rods. So there's very little chain involved, and we'll see if it breaks chain again. We'll remove the front sprocket and put a steel disc there with a lever, and there won't be any chain at all.
Yeah.
But sometimes you hear people say, "Well, I can go to the gym and I can leg press 300 pounds, so I can put 150 pounds in each pedal."
Mm-hmm.
Well, yeah, when you start from a stop sign, the first pedal stroke you can, but after that you're moving forward.
Mm-hmm.
And if you were to put even 50 pounds on the pedal at 60 RPM, you'd be generating like 5 horsepower, and guess what? You can't do that.
Yeah.
So when you're pushing the pedals, you're not pushing. I've tried to look online to find data, and I haven't been very good at it.
Mm-hmm.
People say, well, I can stand up on a road bike and put all my weight in the pedal. I don't think you can totally remove your weight from the pedal that's coming back up. Again, if you could, at 60 RPM, you'd be generating 4 horsepower. You can't do that. That's just impossible. So we're testing at 80 PSI, which breaks chains. When was the last time somebody broke a chain like that? No impacts, no salt and rust and weather.
Mm-hmm.
Nice, warm, cold at the time. Like that. No, not broken in a warm room. It's cold now, but a couple months ago it was warm. So as you know, on some recumbents where starting from the stop sign, you push on the pedal, the one in particular, your seat will rub on the back tire. If the mesh is extremely tight, but it only happens coming away from a stop sign.
Yeah.
That's the same thing. You can only generate that much pressure from a stop sign. So we're over testing it, but that's what we want to do.
Yeah.
We want to make sure that it's super durable. Because, to be honest, the Iowa vintage linears made before 2002, they had structural problems. And we knew that when we bought their assets and moved them to New York. Okay, we're going to redesign it. We're going to beef it up. We're going to figure out what's wrong and fix it. And we're pretty happy. We haven't ever had a frame that we build break. One person broke a derailleur hanger with a derailleur hanger that was actually from Iowa. Nobody's ever broken even a derailleur hanger in an Iowa bike.
All right, let's fire it up and see what it does.
Okay. So it's pushing on one pedal, and then on the seat, and then the other pedal, and then the seat again. Okay. And if you look close, you can see the pedal at the bottom right moving sideways a little bit. It'll tell you which pedal. Like now it's firing this pedal. Now it's firing that pedal. Back to the right pedal. See, it flexes laterally down.
Now, these gauges aren't moving. Why don't?
Yeah, these gauges are to test how much air is actually right at the cylinder. So I'll turn this one on. And you see it's working. It's running 85 pounds there, which is good. But we don't leave them on because over the course of a few frames it would get several million cycles and it would wear out the gauge. So I'll clean them off. Everything will wear out. Millions of cycles, it wears out. So, this frame weighs almost 400 pounds to test a 6-pound bike frame. Well, the frame will last forever.
Yeah.
It won't. The way this is all gusseted and triangulated, and very rigid. And this is using the adjustments to adjust the pressure up and down.
Oh, that's cool. So you just pull the thing up and down?
Yeah, pull it up and twist it, and I can turn it all the way up to and down. It'll go up to 160 pounds. We usually keep the air compressor at 120 pounds. And that gives us $2,000. But it's been money well spent to build it. It's a lot cheaper to find out what's wrong with your product before you ship it to anybody.
Yeah.
And, so we're happy. And we got some new stuff planned. So right now our bottleneck in development is to break this frame and get this one in there. This is going to be this frame. We will modify that before spring. It's going to be slightly different. Not because of durability. Actually, will be a little lighter. This is ridiculously durable. Actually, it's ridiculous. One of the students that worked on the design of this frame, when he graduated, he used his senior project as a. Let me turn this thing on. He used it to show the prospective employers. So these companies would send engineers to look at the different engineering students, and two of the engineers that looked at his senior project said, "Why are they building this so ridiculously durable?" His professor also said that. He said, how long do you want it to live? I said, well, I want it to last forever. He said, you want them to will it to their grandkids? I said, yeah, that sounds good. He said, well, they will. But we'll see.
Okay, I don't think I have any more questions. It about covers it.
Good. We'll turn it back on and keep that million cycles
All right.
going. Come back in about a week and we'll see if we can show you a fracture.